many situations. So which situation does it apply to that we're going to do? A few things you need to know, okay? Number one, your slope or your rate of change. So your slope is your rate of change. They are the same thing. It can be straight line, and that means that it is constant. Or it can be curved. If it's curved, then it can be increasing, or your rate of change can be decreasing. Okay. Next, the other things that we looked at, just to review, for your graph, this is your independent variable. It is your x values. This is your dependent variable. It is your y values. You want to do a depends on sentence to decide which one's dependent and which one's independent. So this is your independent. This is your dependent. 90% of the time goes as your independent variable. Okay, so time would be independent. So we just covered a lot of important information there. Good. So using, yeah, there we go. Any questions so far? Okay, let's get going here interpreting graphs. So today we're going to look at more science type graphs, physics type graphs, and kind of getting into a little bit of statistics as well. So we're going to read here, which graph best represents the following rates of change? So we're looking at our slopes. The slopes will key us into what's going to go on. The temperature of a cup of hot tea over time. So you have a hot tea. What's going to happen to the temperature? Yeah, the temperature will decrease. So A, B, C, or D, which one's showing starting with a high temperature and then it decreasing? B. Okay. So what's your independent and what's your dependent? Temperature and time. Which ones? Does time depend on the temperature? No. Temperature depends on the time. So this would be your temperature and this would be your time. Okay. Temperature depends on time. Well, the next one, the speed. Okay, thinking about speed of a bike over time as you go up and then down a steep hill. So what happens to your speed as you go up a steep hill? It decreases. Okay, and then what happens when you go down Marshall Hill? It increases. So which one's showing speed decreasing and then speed increasing? Definitely. Okay, so graph D. So we're doing speed over time. Where does speed go? Where does time go? Does speed depend on time or time depend on speed? Speed depends on time. Okay. A car accelerating at a constant speed. Yeah, constant. That's going to be graph A. All right, so we have speed and time. And it shows acceleration going constant. So the constant is going to be your straight line. That's the key there. Okay. It's the only one with a straight line. What about height of a football as it gets kicked? It goes up and then down. So it's graph C. So this would be the height. Height depends on time. Okay, it goes up and then down. Good. Label the dependent and independent. We just did that as we went along. Okay, so we went along. Remember, this is your dependent and this is your independent. Okay, summary. Please read the summary. So, underline straight lines, constant rate of change. That's important. The steepness indicates the rate. Okay, so a straight line versus the steepness indicates the rate. Which one's changing faster? Line A or B? B is steeper, so B is changing faster. Okay. Curves are used when the rate of change is not constant. So we talked about increasing or decreasing. Now, horizontal line means something's happening, but there's no change in the rate of change. Okay? So there's no rate of change, it's just constant. Any questions? Okay, let's have a look for part B now. We're going to use some information as we make a story. But before we make a story, let's interpret the graph and answer the questions. A, B, C, and D. Go. Try and answer those 4 questions. How long is the plane in air? 15 minutes. Okay. This, there we go. So this is your total x-axis time. Okay. So a total of 15 minutes. What's the plane's maximum height? 6 minutes. Totally. Okay. What's the total vertical distance? So vertical means up and down distance. So here they travel up how much? 6 meters. Then they travel down how much? Then they travel up how much? And then they travel down how much? Add it all up. What's the distance going up and down total? 16. Okay. 16 meters. Good. Sorry? Oh, you're right. I said minutes. Thank you. Meters. 6 meters. All right. Any questions? So let's do D now. Describe the journey. So from A to B, what happens? Yeah. Constant. That's important to know because it's a straight line. Increase of 6 meters in height over how many seconds? Sorry, how many minutes? 3 minutes. Okay. So I have constant, I have increase in height, and I also have the numbers and how long it took. Okay. Well, from B to C, what happens there? No change in height for 2 minutes. Does that mean the plane's not flying anywhere? Oh, it's flying. It's going around in a circle, right? Or flying straight. It's just not going up or down. So something's happening. The height's just not changing. Okay, so there's no rate of change. What about C to D? What's happening there? Yeah, it's constant what? Good. Constant decrease of 2 meters over how long? 4 minutes. Okay, so constant decrease of 2 meters over 4 minutes. Okay, you do D and E. Go. So DE, you should have a constant increase of 2 meters over 1, 2, 3, 4 minutes. And EF, constant decrease of 6 meters over 2 minutes. And what's happened? What's happened there? Plane landed. Okay. So great description telling what happened overall. Plane has landed. All right. Now AB, you could definitely say plane took off too if you like. Okay. Any questions? So what you need to do on your graphs and your homework is there should be points. Tell me what happens at each point. Now imagine if you graphed your distance from home. Okay. Try and graph that real quick. This would be your distance. This would be your time. What would that look like? Yes, what do you want? No. What's going to happen over time? Sorry? Well, let's say it's the distance from your house. So as you get closer to school, what happens to your distance from your house? Further away. So you start at home, you walk to school, you stay there for a couple blocks, walk to the Husky, maybe it's further from your house, stay there for 5 minutes, so you're not late, you hustle back, and then you're at school for the afternoon, go to a friend's house, chill out for an hour, go to another friend's house who's further away, chill out, and of course your stomach says, go home, dinner time, and so then you go home. Isn't that a wonderful story? You're welcome. Okay, thank you, thank you. Hey, that's just improvisation, folks. See? Natural. I should be. I'd run that show. Okay. Oh, wait, it's not funny. So, anything can tell a story. This is just your distance from your house. Now, if you talked about your distance away from school, well, that would look different. Because you would start away from school and then go to school. Then you'd be there, and then you'd go to the Husky, and then you'd stay at the Husky, and like, holy cow, I'm late. And you'd sprint to school, and then you'd stay there, go to a friend's house, stay there, go to another friend's house, stay there, and then go for a jog around Mill Lake, and stay, jogging takes a while, and you're like, oh, it's dinner time, oh, my stomach's talking to me, sprint home, and pig out at home, blah, blah, blah. Good. Any questions? Yep.
You'd be at school now, though.
Sorry?
You'd be at school now, though.
That's true. And you're right. Oh, good. So Jordan pointed out something. He's like, we need to be at school, Mr. Barker. Let's say Mill Lake was there, and then you hurried home for dinner, and you're back at home. Make sense now? Thanks, Jordan. Obviously, improv has its casualties. Anything else? Okay, don't forget to tip your waitress. Interpreting graphs. Turn sheet over. So, read this real quick. There's tons of information just in this little bit. I want you to have a look and we're going to talk about it. Go. Think about what's your independent and what's your dependent variable for each graph. Studying the birds and the bees. Oh, sorry, just the bees. They're looking at the number of bees over time. So, does time depend on the number of bees? No, number of bees depends on time. Okay, so you should have those underlined. Please write this. Don't waste your time. Let's go, folks. Write it down. So this is going to be your independent, and this would be your dependent, making this your y, and this your x. Notice in the chart, time is x, and number of bees is y. Usually we always list it x, y, right, Andrew? X is what? Nope. Andre sold you out. X is in time, and Y is the number of bees. Okay? So you have it backwards. Write your sentence, Andrew. Okay. Any questions? Now, for this type of data, does it make sense to plot numbers in between 2 and 5? Does it make sense to have 3 bees? 4 bees? What about 2.5 bees? Do you think Josh would count 2.5 bees in the hive? No. Maybe on the windshield, but not in the hive. All right? So you're looking at whole numbers. This is called discrete data. Discrete, you're looking at whole numbers. So, should you join the points? Does it make sense? Does it make sense for values in between? In other words, decimals. If you go to Superstore, you're not going to buy half a jug of milk. They won't let you, right? It's either the whole jug or no jug. And if you drop it on the floor, no, actually I didn't pay for it because blamed it on the kids. Not good, but anyways. So it doesn't make sense for some things to have the points plotted. Sorry, connected. Let's plot Josh's data real quick. So Josh, for time, he goes from 0 to 19. And if we count, let me just make this smaller so it's easier to see. So when you count, you're going to count all the way across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 19. So we need 19 minutes plotted, and there's 19 squares. So what we should have is each square is 1 minute. Okay, so 1 minute per square. Makes it nice for us. Now going up, we have a total of 26. So let's count how many squares going up. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 26, 18 squares. Divide on your calculator. 26 divided by 18. 1.44 repeating. So each square should represent how many bees? I said number of bees on purpose, didn't I? Because a lot of you probably going to say 1.5.
2.
Yeah, so we should go to a whole number for bees. So let's go to 2. So each square going up represents 2 bees per square. So you got to figure this out first before you start graphing. Don't make each square 1.5 bees. That would be really awkward to graph. Okay, so using a ruler, make a grid. Okay, now you don't have to count each one, right? Here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 10. 1, 2, 3, 4, 15. And I think I plotted plotted it wrong. So this here is 5. Here's 10. There's 15. Okay, so you don't have to label each one. Now this is time. And time is in hours, so you should put it in brackets. Usually we have more room there, don't we, folks? But you got to label that axis. You need to tell me what it is. For bees, we're going up by 2. So 2, 4, 6, 8, 10. 2, 4, 6, 8, 20. 2, 4, 6, 8, 30. Okay, and this would be the number of bees. And that tells you what you're going up by it tells you your units as well. Okay. So what I want you to do now is plot the points, please. Go ahead, plot your points. Don't forget a title on your graph. This would be the number of bees at the hive or in the hive. Something that's descriptive about the data, please. Next one. So now we're looking at time and temperature. Again, we go X and Y, and we use our depends on sentence to check. We're saying the temperature depends on time. Are they in the correct order? Should we switch them around? What do you think? They're good. Okay. So this here is your dependent, and here is your independent. Almost all the time is time independent. Okay. So usually when you get time, put it on your x-axis. So this is your x and your y. So for your time, we're going up to 19. That makes sense to have it again 1 square each. Okay, so 1 hour per square, because it's just the same as the other one. But what we can do is we're going to cheat here, and I'll show you what I'm doing. I'm going to put my grid line down. You can do the same. Oops. Okay, so put your axes down. Now what I'm going to do is do a little squiggly line at the bottom. Squiggle line. What that means is that's 0, but I'm going to jump up to 12. So I'm going to take a little picture above 12 degrees. So it's cheating a little bit. So what we're going to do for temperature, because everything's between 12 and 26, that means I only have 14 degrees I have to plot. And there's 18 squares. So what's 14 divided by 18 on your calculator? 0.77. So we're going to go 1 degree per square. Okay. So we can calculate that out. So this will be 13, 14, 15, 16, 17, 18, 19, 20 all list. 21, 22, 23, 24, 25, 26, 27, 28, 29. Okay, so don't list every one. That's just complicating your graph. Okay, list every 5. Once I got on the 5s, is easy to do. Questions? Carmel? Sorry, Peniel, sorry. From 12 on, I went up by 1. Okay, and because I did this little squiggly line, that means pretend the graph, instead of starting at all the points being up here, I just smushed them down a bit. Okay, so that allows you to save some graph paper. You don't see that all the time. Okay. Okay, so going up by 1s down here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is 10. 4, 5 is 15. Good. Again, this is time in hours, so H in the brackets. This would be temperature, and it's degrees Celsius in the brackets. Okay, so go ahead, graph your points. Okay, now since temperature you can do decimals, right? 19.1 degrees, 19.2, 19.3. It makes sense to connect these with a line because there's going to be values in between. So what I'm going to do is just connect these with a line from point to point. Okay, so I can connect them with a point with a line using a ruler is best. It's also good to use a different color so you can clearly see. Now, in science, sometimes you're going to do things like a smooth curve. We don't have to do it for this one, okay? You don't need to do smooth curves for here. Although you could, but we're going to connect them with lines. Okay? So, discrete data are data values on a graph that are whole numbers. So they're going to be points that are not connected. Okay. Points not connected. Whereas discrete values on a graph are, they could be integers / decimals. And so then the points will be connected. Okay. So the reason why is discrete data can only show points because the values in between have no meaning. Right. Now the exception is with large numbers. So for example, if I'm plotting the number of houses I sell or sold in the Fraser Valley, you'd be looking at things like in the thousands, right? So if I'm selling thousands of water bottles, if I'm plotting 1,000 and 2,000 water bottles sold, well, it would make sense to connect the dots then because there's numbers in between, right? That does make sense. Okay, so you'll see that once in a while. So what you need to do is ask yourself, should this be whole numbers? If it's whole numbers, don't connect the dots. And you see it wrong all the time. All the time. Some graphs are horribly done in the media, in the newspaper, and because they're published, you think, oh, that's really good. That's the way I'm supposed to do it. Not. I'll show you an example right now. So, unfortunately, the data isn't that great. We're talking about the drinking age. What's the drinking age in BC? 19. Was in Alberta? 18. So that's a difference of how many years? 1. Well, check out this graph, folks. This graph makes it look like the drinking age of Alberta is half the drinking age of BC because of the way they've drawn it. Is that not misleading or what? Like, there's no way they should have been able to publish that. It's ridiculous. Alberta's half BC. That's exactly what it looks like. And then you look at the numbers and like, what? 18, 19? I mean, that's just horrible. And if you look at the grid lines, like what do the grid lines mean? Right? BC is 1, 2, 3, 4, 5, 6, 6 and a bit squares. Like, what would that possibly represent? I can't figure it out. Whereas Alberta is 1, 2, 3 and a third of a square. It's like each grid represents 6 or something like that. Unbelievable. Okay, it's just ridiculous. So sometimes you're going to see graphs in the newspaper and you see them all the time. It doesn't even make sense. They're kind of painting an incomplete picture. So they say pictures say 1,000 words. Make sure yours says the right 1,000 words. Don't draw a wrong graph. Speaking of wrong graph, what did I forget to do in the notes? Thank you. Go back, please. Make a title. So this would be the temperature of honeycombs, or the hive. Okay. There you go. A nice descriptive title. So when I'm going to check this, I'm going to make sure you use proper scale. You do not want to do this and scrunch your graph into this little corner of the graph paper. Okay, that's horrible graph. I'm going to take marks off for that. All right. On your homework, you can kind of divide your page into 4 quadrants and do 4 graphs on one page. Or if you want, you can do a whole graph on a page, that's fine. Okay, no big deal about that. Any graphing questions? Any questions at all?